So, hi everyone. Continuing in the spirit of looking under the hood, that's precisely what we're going to be doing today. And I will talk about, from a more environmental and sustainability lens, what exactly is under the hood of AI. As today is supposed to be a day where we shift our gaze from, oh shit, to what's next, that's what I want to do by shifting your gaze on three specific areas. These refer to also what Trudy touched upon, is let's make AI not ethereal and hand-wavy and magic. And often when we think of AI or other such emerging tech, we think data, we think zeros and ones. But there is actually a huge material footprint that lies under the hood. So that's the first thing I want to shift. The second is the rhetoric of automation. If we look at the history of tech, and I will come to that in a bit, always there is this idea of replacing labor. And I want to show you that that also is a sort of a thing that trips us here. And the third, as many of the talks in this conference have touched upon, is this idea that we are somehow outside of our biosphere. So this is the third shift. Okay, so let's start looking at the invisibility of data, infrastructure, ecosystems, and labor. The picture you see over here refers to the early stages of industrialization in Britain, where we were moving from the loom to the actual machinery that went to automate the process of the textile industry. And the history of tech shows us that there is this sort of almost myth that goes around that automation will equal progress. And if anything we've learned from history is that no, every fight has been hard won. And this is not different in the case of AI. So when you saw early agricultural systems changing, when you saw textile mills coming in, when you saw the Industrial Revolution, power stayed in the hands of elite. And there were huge movements, labor movements, that tried to equitably distribute it. On the materiality question, this is a snapshot of what a GPU looks like. And this is what a lump of silicon looks like. The reason I put it up there is because the critical minerals that go behind the fueling of what we call a green transition are very fraught in terms of where they come from. They come with a footprint based on the mining, where the resource lies, and those communities getting access to the risks and rewards of that. That is a snapshot of a pit mine, what it looks like, where currently around the world, mostly in the global south, these critical minerals are being sourced. In his book, Sebastián Salgado talks about the archaeology of industrialization. What you see on the left, or my left, is a gold mine. And to the right is what the Industrial Revolution's factory setting looked like. The Mechanical Turk is another example of making invisible the footprint of labor in automation. Coming from there to AI, many of you might be aware of investigations which show how data is labeled, how is it categorized, who does this, and how are the risks and rewards being distributed. So that very ethereal nature of the AI revolution, when you look under the hood, you see disparities in countries like India and Kenya and the Philippines, where data workers are currently fueling the revolution. But that's on labor. Very quickly, on the water footprint. Now we move to the actual material, hard planetary limits. In carbon, we often talk about three-scope emissions: first, second, third. Water has a similar footprint. So you have first scope emissions, first scope water footprint, which is the actual cooling on the site where the data and the server farms sit. You have second scope, which is where the power grid is, which is being used to cool these systems. And the third, which is very seldom talked about, is in the manufacturing of those chips. Do you remember the picture I showed you a while back of the GPUs? Incredibly water intensive to make. And where this is being done currently are in areas of water scarcity around the world. So there is a less talked about material footprint of water, Similarly, we have on energy use and carbon emissions. Here you see it depends on the task. So as we move from text classification and simple language, relatively simple language work, all the way to generative AI, by magnitudes, way higher emission in terms of the carbon and energy footprint. So what I wanted to point to you here, instead of the doom and gloom, is that some of the extractive narratives that we saw in the history of science and technology are being repeated here, whether it's on the thirst, whether it's on land and data grab, whether it's on ghost labor, and the geopolitical risks and dependencies. There are existing what we call unequal geographies, and often what you see is shifts in the value chain, whether it's to do with the semiconductor shortage or where lithium is being mined, to where the ownership of the supercomputation sits, which companies have access to the largest amounts of data and the computational power. It's that discrepancy that I want to bring to your attention. From there we go, and linking to yesterday's how did we get here, I just wanted to point your attention to the top over there. I know it's really small and hard to read, but in the few years from the Second World War, we see extreme material extraction, extreme acceleration, whether it's to do with critical minerals or to do with CO2, fossil, and water withdrawals. So this is how we're here. And it's an inflection point, as Trudy mentioned, in terms of where AI capabilities are taking us. So we see massive amounts of possibilities, but this is something we need to keep in mind. Today's keynote also touched upon planetary boundaries. We are at the crossroad where of the 9 boundaries, 6 have already been crossed. So moving from there to my last few slides on what now. I feel that there are some real things we can do. Within Europe, here in the Nordics also, there is a huge movement for responsible AI, regulation, policy instruments, and a global governance is much needed in this area. We also heard a little bit about the tragedy of the commons. So could AI ever be a common pool resource? This is something worth thinking about in terms of shifting our perspective on this topic. And finally, could AI be also used to imagine new futures, as currently our foresight work is doing with the IPCC or in the UN reports looking at future scenarios? We need to challenge our assumptions. Automation comes with this problematic equation with progress. When you do foresight, you need to challenge your assumptions. Supply chains. One very helpful concept that we work with in climate science is called transboundary risk, how what you do in one area affects somewhere really far away. I think that's a very helpful metaphor to use when thinking of AI and emerging technologies, to help us think of scope 3 impacts of the technology. And finally, equity. It's normative, yes, but very contested ideal. How do we design for equity when we design technologies? These are some of the assumptions and thoughts that I want to leave you with. And my final slide, kind of playing on what Trudy also mentioned, is yes, there is a lot we can do with optimization. We can tweak our algorithms, we can make it more energy intensive here, but there's also a very important and provocative idea of when not to use AI, when not to design with certain tools. Thank you. I'll leave it there.